Hello and welcome to the summer assignment tutorial videos. In these videos I'm going to pick out a couple problems from each section of the summer assignment to work as examples to try to give you guidance on how I want you to work these problems. And remember, these problems are meant to be a review of previous courses, previous content that you've seen in Algebra 2 or in Trig and Pre-Calc, and to get us kind of warmed up and ready to hit the ground running when we come back to school in August for AP Calculus. So let's start on the first page in the first section, and we're asked to factor completely. Now we're not solving anything, we're only factoring. So let's take a look at number 1 here when we have 9x squared minus 36y to the 6th. Alright, first thing you always want to do whenever you want to try to factor something is look to see if there's a greatest common factor. And in this we do have a greatest common factor of 9, and so we're going to factor that out, and we're going to get x squared minus 4y to the 6th, and that whole quantity times 9. Now one thing that we should notice inside of our parentheses here, this quantity, it is not a trinomial that we would factor in the traditional fashion, but it is a difference of two squares. The first term is a perfect square and the second term is a perfect square, so we can factor that using the difference of two square rule to say that this is going to be x minus 2y cubed, because x squared is x squared and 2y cubed squared is 4y to the 6th, and then x plus 3y cubed. And then we have to ask ourselves, are all of these pieces factored completely? Well, 9, yeah, you could split it up into a factor of 3 and 3, but we're not going to do that. We're going to leave it as a coefficient. We don't want prime factors of coefficients here. X minus 2y cubed, that's as far as we can go. Same thing with x plus 3y cubed, can't factor it anymore. So this is factored completely. Now you're going to do this as well for 2 through 5, but one thing I do want to point out is on number 4 and 5 you're going to have to remember the sum and difference of two cubes. And in case you forgot that, the simple formula is a cubed plus or minus b cubed is equal to a plus b, that quantity, times a squared minus ab plus b squared. And then that will have a minus and a plus there as well. So you're going to use this for numbers 4 and 5 to factor a sum or difference of two cubes. Let's take a look at this next section here where we want to find the domain and range using interval notation. So let's pick this simple one here of number 6 to illustrate our point. And first we want to look at, well, what is domain, what is range? Well, domain corresponds with the x. So what is our lowest x value, what is our highest x value? What parts of the independent variable are we defined? And so if we look here, our lowest x value is 1, right there. We have an x value of 1, and our highest x value here is 7. So we would say the domain, and we wanted an interval notation, so this might be a little different, and if this is new to you, just learn this notation. This is how I want you to write it from now on. X is defined, and that's kind of like a little epsilon there. X is defined from 1 to 7. Now, the key is we have closed brackets here because we're including 1 and we are including 7. So x is defined from 1 to 7 because 1 is our lowest x, 7 is our highest x. Well, we're going to do the same thing with our range, and we look at, well, at this point, our lowest y value is a negative 3, our highest y value is a 9, and we're defined everywhere in between, so y is defined from negative 3, and we want to include negative 3, to 9. Now, what would be an example where we wouldn't want to include negative 3 or 9? That's if we had an open circle. Okay, now in none of these graphs do we have those open circles, but if those were the case, then we would change our domain or range accordingly.